Hello, welcome again. We are covering the subject Steam Engineering for Civil Services Mains, IFS and various gate exams. Next topic in the chapter of analysis of steam cycle is reheating of steam. In the last video we studied that the at the exit of the turbine the dryness fraction should not less than 0.8 or the moisture content should not exceed 0.12 and the maximum pressure is fixed by this condition. Okay. So now if we want more pressure than this pressure, then reheat has to be employed. To increase the overall pressure, reheat has to be employed. So what is reheat? Reheating of steam. So here, suppose this is your turbine inlet. This is your turbine inlet at 1, and steam is leaving the high pressure turbine at 2s, and then it is again heated or reheated, and after reheating it is fed to low pressure turbine, and then after expansion in the low pressure turbine it goes through condenser. Okay. And after leaving condenser at 5 it is fed to pump where the pressure is increased to 6s, and then it is fed to main boiler where it is heated and again fed to this high pressure turbine, and this cycle is repeated. So here new thing is this part, reheating. So reheating of steam is done after the expansion in high pressure turbine. So if we study the diagram or TS and HS diagram, then this is your 1 2s process, or this is HS diagram, this is 1 2s process, or this is the process in high pressure turbine. Okay. And then this is reheating 2s to 3 process. Okay. And then it is expansion in low pressure turbine 3 to 4s, and then condensation 4s to 5, and then pressurized 5 to 6s, and then heating and superheating 6x to 1. Okay. So this is the cycle. So here what we are able to achieve, that if we do not reheat, if we use simple cycle, then this expansion would be continued up to 0.4s dash. So here the moisture content is more. So by reheating the steam we are able to reduce the moisture content. Okay. So or we are able to increase the dryness factor. So that is the one of the advantage of the reheating. And by reheating also we can see that we are getting this extra area. Okay. This extra area. So this extra area means more work obtained. Okay. More work obtained. So work output of the cycle also increases. So one of the advantages, dryness fraction increases. Okay. And work done is achieved. And if we look at the efficiency, so higher this reheat pressure, higher would be the efficiency, because then mean temperature of heat addition would be more if this pressure is high. If we take reheat here, then efficiency will be more. If we take reheat here, then efficiency will be more. Okay. So this limit is fixed by reheat pressure by P1 pressure. So this limit is kept above 0.25 to increase the efficiency and or to increase the mean temperature of heat addition. Okay. So these are the advantages of reheat cycle, and now I will read out this and explain each and every point. First point is, if a steam pressure higher than P1 max is used in order to limit the quality to 0.88 at the turbine exhaust. The reheating of steam has to be noted. So that is the first point, that if we want the higher pressure than P1 max that we have studied in the last video, then reheating should be used. In that case, all the steam after the partial expansion in the turbine is brought back to boiler, reheated by the combustion gases, and then fed back to the turbine for further expansion. So here you can see that after initial expansion we are reheating the gases and then fed back to low pressure turbine. Okay. The flow TS HS diagram of the ideal cycle with reheat are shown here. Next one is, in the reheat cycle the expansion of steam from initial state 1 to condenser pressure is carried out in 2 or more steps depending upon the number of reheats. So here only one step is there. So here reheating is done from 2s to 3. Okay, so only one step is there. In the first step, steam expands in high pressure HP turbine from the initial state to some intermediate pressure, process 1 to S. The steam is reheated or recuperated at constant pressure, process 2S to 3, and remaining expansion, process 3-4S of steam is carried out in the low pressure turbine. So this is 1 to 2S, this is 2 to 2S to 3, and this is your 3 to 3S. Okay. Now for 1 kg heat added is your main heating, that is H1 minus H6S and superating H3 minus H2S. Okay. So heat added is this, and heat rejected is that is same, H4S minus H5, H4S minus H5, and work done is in two turbine. In first high pressure turbine is H1 minus H2S, and low pressure turbine is H3 minus H4S. H1 minus H2S plus H3 minus H4S, and pump work is H6S minus H5. Okay. So the efficiency Wt minus Wp by Q1, Wt value is this, Wp value is this, and Q1 value is this. And steam rate in kilogram per kilowatt hour is 3600 by W net, and heat rate is 3600 by efficiency. So this is in kilojoule per kilowatt hour. Okay. So if had the high pressure P1 been used without reheat, the cycle would have been 1,4-S5,6S. So this would have been 1,4S-5,6S. Okay. With lot of moisture at the turbine exhaust having quality X4S. With the use of reheat, the area 2S, 3, 4S, 4-S has been added to the basic cycle. It is seen that the net work output of the plant increases with the reheat because H3 minus H4S is greater than H2 minus H4S dash, and hence the steam rate decreases. Next one is reheating also improves the quality at the turbine exhaust from X4S to X4-S to X4S. So here this would be the quality if reheating is not done, and this is the quality if reheating is done, and this is the extra area. And the last point is the cycle efficiency improvement depends upon the mean temperature fluctuation, which in turn depends on the reheat pressure. Generally PRS by P1 is kept above 0.25 to